Welcome to the Calculus 2 class. Today, we will learn a powerful tool called ratio test. First, we're gonna apply the ratio test to determine where infinity series converge or diverge. It will help us decide where an infinity series converge or diverge, especially when terms include factorial, powers, exponents. We'll start with the idea behind it when see how tests work. Here is how it works. When you see the series summation n equal 1 to infinity an, we take a ratio of consecutive terms an plus 1 over an. Look at what happens as n gets very large. This ratio approaches the number less than 1, then we're gonna say series gonna converge, absolutely converge, and therefore converge. The ratio gonna be greater than 1 or ratio gonna be infinity, then series gonna be diverge. However, ratio L equal 1, this ratio test is inconclusive. You have to find another test to determine if the series converge, diverge. When do you use ratio test? What kind of a series is suitable for ratio test? Each term has factorial or exponential form. You definitely use ratio test. Let's have first example. Look at this series. This series exponential term in the numerator, factorial term in the denominator. That case, you definitely use a ratio test. First, what is an? An equal 2 to the n over n factorial. We need the next term, an plus 1. You're going to replace n with n plus 1. So an plus 1 equal 2 to the n plus 1 over n plus 1 factorial. Now, we're going to calculate ratio of consecutive term and take a limit. Look at this, L equal limit and approach to infinity, an plus 1 over an. I want to rewrite an plus 1 over an. That's gonna be an plus 1 times 1 over an. So I put the an plus 1 right here to n plus 1 over n plus 1 factorial. 1 of an gonna be reciprocal of an. That's the n factorial of 2n. Now, what do you have? Right here, guys. 2n plus 1 over n plus 1 factorial times n factorial over 2n. Now, what do you want to do? I want to switch n factorial to n plus 1. So I switch it. Then I want to simplify. So first, you're going to see n plus 1 factorial, meaning is n plus 1 times n factorial. 2n plus 1, meaning is 2 times 2n. Now, what do you have? n factorial over n plus 1 factorial gonna be n plus 1 times n factorial. 2 to the n plus 1 gonna be 2 times 2 to the n divided by 2n. Now let's just simplify. N factorial cancel out. 2n is cancel out. What is left? You see right here. 2 to the n plus 1. Now, can you evaluate this limit? N approach to infinity. 2 to the n plus 1 should be going to where, guys? That's going to 0. So this limit gonna be 0. So ratio test say we find the limit of consecutive ratio of consecutive term, L gonna be less than 1, our conclusion gonna be this series converges. Let's have second example, guys. Second example, look at this. Summation 2 to the n over n. Here's a key point. Here is power, exponential form. We can use ratio test. an gonna be 2n over n, an plus 1 equal, n gonna be replaced with n plus 1. That's why an plus 1 equal 2 to the n plus 1 over n plus 1. We want to find the limit of ratio of consecutive terms. That's what we're going to calculate. Limit an plus 1 over an. So an plus 1 times 1 over an gonna be 2n plus 1 over n plus 1. 1 over an gonna be n over 2 to the n. Now, what do you have here? an plus 1, 2 to the n plus 1 over n plus 1. 1 over an gonna be n over 2n. So let's switch to n plus 1 right here, guys, to n plus 1 and n. Switch it, that spot. So you have n over n plus 1, n over n plus 1, 2 to the n plus 1 over 2 to the n. What is 2 to the n plus 1? That's gonna be 2 times 2 to the n. Now, what do you see here? N over n plus 1, 2 times 2 to the n over 2 to the n. Which one is cancel out? 2 to the n. 2 to the n is cancel out. Now, what do you have here? You have 2n over n plus 1. 2n over n plus 1 is positive. You don't need the absolute value. So now we can find the limit of that sequence by using the L'Hopital rule. Derivative of 2n is 2. Derivative of n plus 1 is 1. So you find the limit of this ratio. That's gonna be 2. What ratio test say? L gonna be greater than 1 because L value is 2. This series gonna be diverse. Let's have one more example for ratio test. This is a series. What do you see in the series? Can you see this is exponential form? So in that case, this is alternating series, guys. So we want to know this is converse, absolutely converse. Ratio test guarantee if this series converges absolutely. So let's do the ratio test. First, we have find what is an. An gonna be negative 1 n minus 1 n cube over 3. And now you're gonna replace n with n plus 1 for an plus 1. So what is gonna be, guys? Here is, very careful, n plus 1. N gonna be n plus 1 minus 1. That's gonna be n. N is replaced with n plus 1. Here is n replaced with n plus 1. That's the an plus 1. That's the an. Now, we're going to find the limit of ratio of consecutive term. Here you go. We did again. An plus 1 times 1 over an. So you know the what is an plus 1. You know the what is 1 over an. So I find an plus 1. I know the 1 over an. 1 over an is going to be reciprocal of an. So negative 1n minus 1n cube going down the numerator. 3 to the n go to I'm sorry guys, negative 1, n minus 1, n cube go to denominate, 3n go to numerate. Now switch the spots, switch the place, 3n plus 1 go to the next, this one go to the left side. So what you have now, you have this form, negative 1 and n, negative 1 n minus 1, n plus 1 cube, n cube, 3n, 3n plus 1. And take absolute value. Take absolute value meaning is we don't want a negative. So what you see here, guys, you separate each term. First one is negative 1 and n over negative 1 n minus 1. Second term is n plus 1 cube over n cube times 3n over 3n plus 1. This is positive, so I drop the absolute value. What is this value, guys? That value gonna be 1, no matter power n. This always negative 1, positive 1. You take absolute value, that's gonna be 1. Now, what do you want to find the limit? So first, we're gonna simplify here. 3n plus 1 is 3 times 3n. So power here, 3 and 3 same, so I'm gonna put together. So right now, we have n plus 1 cube over n cube times 3n over 3 times 3n. Cancel out 3n. Cancel out 3n, 3n. Now put together, because power is 3. Then you take out 1 over 3. We want to find the limit of n plus 1 over n cube. What is this limit? Limit can go inside the cube, parenthesis. That's gonna be 1. So you have 1 over 3. The limit of ratio is 1 over 3, which meaning is less than 1. So we're gonna say ratio test tells you this alternating series gonna be converse absolutely. Let's have another alternating series. So you see, here is n factorial. Here is exponential form. So we're gonna use a ratio test. What is an? An gonna be negative 3n over n factorial. An plus 1, next term gonna be negative 3n plus 1 over n plus 1 factorial. Let's find the ratio and take a limit. So ratio gonna be an plus 1 over an. Rewrite it, an plus 1 times 1 over an. An plus 1 gonna be negative 3n plus 1 over n plus 1 factorial. 1 over an gonna be reciprocal an factorial over negative 3n. Switch the two term, negative 3n, n plus 1 factorial. Now we have negative 3n plus 1 over negative 3n, n factorial over n plus 1 factorial. Negative 3n plus 1 gonna be negative 3 times negative 3n's power, n plus 1 factorial, meaning is n plus 1 times n factorial. So now, let's just simplify here. Right here is 3n plus 1, negative 3 times is negative 3n. Negative 3n, negative 3n cancel out. We have negative 3. n plus 1 factorial gonna be n plus 1 times n factorial. That's cancel out. So denominator n plus 1, numerator negative 3. We take absolute value, so you can drop the negative. You have 3 over n plus 1. What is this limit? As n approaches the infinity, this going to 0, right guys? That's going to 0. So what are you gonna say from the ratio test? L gonna be 0 less than 1, then ratio test tells you this alternating series gonna be converse absolutely. That's really powerful tool to determine if series converse or diverge. This example shows you cannot use ratio test when you have P series. Let's have example here, guys. So look at this series. This is alternating series, right? Because this -1 n minus 1 over square root to n. 1 over square root to n is P series. P value is 1.5. You cannot using ratio test for this kind of alternating series. So let's start with general term. A n gonna be -1 n minus 1 over square root to n. A n plus 1 gonna be replace n with n plus 1. Power gonna be n, denominator n plus 1. Let's find the ratio and take a limit. A n plus 1 over a n. Next one is a n plus 1 times 1 over a n. So a n plus 1 is -1 over n over square root n plus 1. 1 over a n gonna be reciprocal of a n square root n over -1 n minus 1. Let's switch to this spot. Switch to this place. So you have -1 over n over -1 n minus 1 square root n over square root n plus 1. Let's separate -1 minus 1 over -1 n minus 1 times square root n over square root n plus 1. So let's have this one. So this one is what? That's gonna be always 1 no matter what, because that's the positive negative. We take absolute value. So we have to find limit of this one. So this one gonna be, what is gonna be? This one is put together square root. That's square root n over n plus 1. This limit go inside the square root, then we're gonna find the limit of n over n plus 1. This limit gonna be 1 by L'Hopital rule. Square root 1 is 1, which meaning is L value is 1. What do you say about ratio test? They say L equal 1. This ratio test cannot tell us if a series is gonna be converse diverse. We have to use different tests, but we already know this alternating series converse by alternating series test. So remember that you cannot use ratio test all the time. Depends on series. So factorial, exponential form, you definitely use ratio test, but you cannot use P series. I'm gonna give another example. We cannot use ratio test. So you cannot use ratio test when you have polynomial form. Here is an example. So look at this one. Numerator have n terms. That's degree 1 polynomial form. Denominator 2n plus 1. There is degree 1 polynomial form. That case, we cannot use ratio test. Let's have example here, guys. So a n gonna be -1n times n over 2n plus 1. A n plus 1 gonna be, you replace n with n plus 1, Then here is 2n plus 2 plus 1. That's 2n plus 3. N gonna be n plus 1. N gonna be n plus 1. Let's find the ratio of an plus 1 over an. So an plus 1 gonna be negative n plus 1 over 2n plus 3 times 1 over an, reciprocal of an, 2n plus 1, negative 1n's power times n. So let's just swap the place. You have negative n plus 1 over negative 1n's power. That's the first term. N plus 1 over n. That's right here. 2n plus 1 over 2n plus 3 right here. You know that this value gonna be 1 because absolute value. So that gonna be 1. Now you have n plus 1 over n, 2n plus 1 over 2n plus 3. This all parts, you can drop it right here, and then you're gonna find the limit of each term. So n plus 1 over n, 2n plus 1 over 2n plus 3. You can use L'Hopital for each limit. So first one go to 1, second go to 1. So you have 1. L gonna be 1. When L gonna be 1, we cannot decide if this series converges diverse. But if you use alternating series test, we know this series converges. What did we learn in this session? We learned ratio test. Ratio test compares consecutive terms to see how quickly they shrink as increase. So that's we have calculated L value, limit of ratio an plus over an. L value is greater than 1. We're gonna say this series diverse. L gonna be less than 1. Series converges absolutely. L equal 1. Test is inconclusive. We have to use another test. Also, when you use ratio test, if series has factorial, powers, or exponential. Don't use ratio test when series have p-series or polynomial form.